of 1,000 racing cars, Skylab thundered toward space in May 1973. Its mission, to explore the Earth.
Still some doubt in the minds of flight controllers here in Mission Control as to whether the main solar panels on the workshop.
Skylab was the refitted third stage of a massive Saturn V, the central part serving as a workshop. Solar panels providing electricity for running the station, one panel each side of the workshop, and 4 wing-shaped arrays for experiments. When Houston got word a solar wing had been ripped off during launch, a special umbrella was made to protect the workshop hull, exposed by a sun shield that also came off. Now Skylab astronauts would have to fly a rescue mission to save the crippled space station from heating up in the scorching sun and running out of power. Controllers soon learned the other solar wing had been snagged by debris when the first panel tore loose, so without a helping hand, that too would be unusable.
T-minus 17 seconds and counting, T-minus 15. At T-minus 3.1 seconds, we'll expect the engine sequence to start on the vehicle. T-minus 7, 6, 5, 4, 3. Engine sequence start. 2, 1, 0.
10 days late and packed out with sunshades, giant scissors, and a tool chest the envy of a motor mechanic, Conrad, Weitz, and Kerwin rode a Saturn 1B to the limping laboratory with an exhilarating call from the commander.
Tower in Houston, Skylab 2. We fix anything. I got a pitch and a roll program. Solar Wing 1 is in fact partially deployed, and the reason that you've got different readings, not symmetric between your 3 solar panels, is there's a bulge of meteorite shield underneath it in the middle, and it looks to be holding it down.
At last contact over the Vanguard tracking station, the crew of Skylab 2 was having difficulty in redocking. They'd made several attempts and were going down through the backup procedures for retracting in and extending the...
Finding it difficult to dock after a quick fly-round inspection, the Apollo capsule pulled back, viewing the long solar wing pinned down against the workshop hull.
Engine control system thrusters, whereas they had been only on 2-jet thrusting during the stand-up EVA to prevent the RCS plume from striking the pilot as he stood in the hatch.
Flight Houston through the Vanguard, how do you read?
Got a hard dock out of it.
Hey, way to go!
With a cry of success, Skylab's rescue crew moved inside. Temperatures were over 100 degrees, and the food freezers were near to collapse in the sweltering heat. First priority was to maneuver the sunshade through an airlock in the workshop wall. And then, with consummate skill, Conrad and Weitz pulled free the one remaining solar wing, putting electrical power aboard Skylab. Two days after launch, Skylab had been repaired. It was a 100-ton hotel with as much room as a 3-story house, enough food for 6 months in space, and a view literally out of this world. America and Russia signed a historic agreement to shake hands in space, and Brezhnev and Nixon met to seal the plan. It was a unique occasion. In Moscow, teams of American engineers, scientists, and astronauts met with their Soviet counterparts. a Soyuz was being prepared for an act of cooperation unimagined when the moon race forged a spirit of unbridled competition. Deke Slayton failed to make it first time round, but would fly aboard Apollo to dock with Soyuz in orbit. Alexei Leonov, the first to walk in space, would command a Soviet ship. Apollo-Soyuz brought cosmonaut and astronaut together professionally for the first time, and for a while, fettered pride evaporated in the struggle against common danger. Essentially a Soviet design, the docking unit was very different to Apollo equipment, and the first of its kind.
Onboard control systems have completed the registration equipment here. Ignition. The power.
In 1966, only months after 3 Americans were killed in a launch pad fire, cosmonaut Komarov died when Soyuz 1 crashed uncontrollably to Earth. 5 years later, 3 Russians died aboard Soyuz 11 when their capsule depressurized in space. The Soviets took special precautions and turned a 3-man spacecraft into a 2-man capsule with spacesuits for both where previously they had none.
Proceeding normally. 40 seconds. The flight is normal.
In June 75, Soyuz, carrying Leonov and Kubasov, roared into orbit, there to reside and wait for an Apollo capsule carrying Stafford, Slayton, and Brand. It would be the last flight of Apollo, the last launch of a Saturn rocket, and the last NASA manned mission to splash down in water. Not for nearly 6 years would another American astronaut fly into orbit.
The engines will actually...
In the control room at Houston, they received confirmation that Soyuz was safely in space. At the launch control site in Florida, everything was ready.
Ready light on. 10, 9, 8, 7, 6, 5, 4, 3, 2, engine sequence start. They're on. Clear the tower.
Two days later, Apollo met Soyuz nearly 200 miles above Earth.
Have you got a good view of it, Vince? Apollo, Houston, I got 2 messages for you. Moscow is go for docking. Houston is go for docking. It's up to you guys. Have fun.
All righty, sounds good. Apollo,
For more than 14 years, the 2 most powerful nations on Earth had challenged each other in space. Now, they would unite.
present you with 5 flags for your government and the people of the Soviet Union.
Joined docked spacecrafts Apollo and Soyuz with the 2 U.S. and USSR flags side by side.
When they said goodbye nearly 48 hours later, it was the end of what many had hoped could be a new age of cooperation. With 2 great powers marching together into the cosmos. That was not to be. TV camera mounted outside Soyuz, a Salyut space station looms into view, its huge antenna dominating the front end. Within seconds, docking is completed. Orbiting the planet with an almost continuous presence of man in space, Salyut served military and domestic functions, testing new equipment and making a comprehensive survey of Soviet territory. Salyut would be home for 2 men at a time, only occasionally going outside to repair or service the orbiting laboratory. And getting inside the suit was a case of using the back entrance and working your way through to the front. Cosmonauts used an airlock to move outside without depressurizing the interior of the main station, frequently taking with them cameras wrapped in covers to protect delicate parts from the sun's rays. Several times, the Salyut cosmonauts went outside to conduct scientific experiments, effect minor repairs, replace worn-out equipment, or inspect the exterior. By the late 1970s, a regular pattern of Soyuz missions took cosmonauts into space, with men from East European and other pro-Soviet countries carried on short trips to visit the long-stay occupants aboard Salyut. New, modified control equipment was built, and an air of expanding commitment filtered through. The Russians were in space to stay. Using contour couches moved through the station from one Soyuz to another, cosmonauts on short visits left their new capsule for the long-stay crew and went home in the older spacecraft. Even the personalized suits were moved from a Soyuz at one end to a Soyuz at the other. The most astonishing saga of all was the record of Salyut 6. It was occupied on and off for almost 4 years. In that time, 19 Soyuz capsules were launched, and very long missions gave a wealth of data on the physical effects of weightlessness. Before Salyut 6, the flight duration record was the 84-day Skylab mission, which ended February 74. Redesigned Soyuz capsules packed out with food, fuel, and provisions instead of cosmonauts, and called Progress supply ships, were sent to restock the stations. Salyut 6 alone received 12 Progress types, keeping it operational far beyond the life of supplies carried at launch. Ferry ships bringing essential equipment doubled as mail carriers for homesick cosmonauts, and even a guitar or two was known to get smuggled aboard. Letters from loved ones and music tapes from the Bolshoi shared room with fuel tanks and dehydrated food. In March 78, the world's first international manned space mission carried a Czech cosmonaut to visit Romanenko and Grechko aboard Salyut. In the next 4 years, men from Poland, East Germany, Bulgaria, Hungary, Vietnam, Cuba, Mongolia, Romania, and France made a similar trip to Salyut 6 and its successor. Setting up the world's first unofficial post office in space, the cosmonauts returned with unique mementos of an exceptional journey. Exercise kept cosmonauts in physical trim, and all the rules of the fitness game that worked aboard America's Skylab applied equally to Russia's long-duration flights. On some missions, 2 hours a day on exercise was a vital part of staying in condition. And a vital part of getting on with a fellow pilot was to take a shower as often as the cramped conditions would allow. The land, agriculture and coastal resources of the Soviet Union gain measurably from the surveillance role of Salyut, providing regular observations of remote areas. The routine flights provide a consistent development for Russian space technology, and long-duration missions look ahead to the day Soviet cosmonauts will head for Mars, a journey that would last at least 7 months. As cosmonauts on long flights return home, the stresses of re-entry put great strain on the human body. Conditions on the ground are not always favorable to a good recovery, and there is always uncertainty about the pilot's condition. To guard against physical injury or harm easily caused to a cosmonaut back from several months in space, caution prevails, and the pilot is gently lowered to the ground. Long-duration flight, a new chapter in the annals of physiology, turning each mission into a pioneering endeavor at the frontier of human knowledge. On the Johnson Space Center at Houston, NASA abandoned the old dinosaurs of the space age to set its sights far beyond the limits of present technology. The huge rockets of yesteryear no longer had a mission. Capsules like Apollo were now showpieces in a museum. A new age was about to dawn. The shuttle would be its cornerstone. For 10 years, Rockwell and a host of subcontractors labored to build the world's first reusable spacecraft, a winged rocket to fly back down from orbit and land like an aeroplane. Carried on top of a Boeing 747, the shuttle would first flex its wings in the atmosphere, proving it could fly like a glider and gently return to Earth under full control. It was a very far cry from the tiny Apollo capsule, yet could sit comfortably on the floor of the shuttle's cabin.
Okay, all operators, go for takeoff. GNC, go. Fido, go. Arrow, go. Loki, go. Network, go. Inco, go. FAO, go. Homer, go. AMR, go. Rockwell, go. Roger, Roger, we're go for takeoff.
Flaps coming to 5.
Okay, Enterprise is set. Next to left, that's. And we're stand by for the bang, Gordo. Not too bad. Okay, she's flying good.
Okay, he's start to turn now. Right.
Enterprise, you're clear to start to turn. Okay, starting to turn the funnel. You got to. Straighten her up, Gordo, not quite space. Slightly low. Okay. Stop her here a minute. Yeah, we ought to be turning at 7. Okay. Have to look for position. Okay. Okay, we are armed and clear. Standing by the gear. Okay, the gear is coming down at 270. Coming down. Mark. Gear coming. Okay, 3 down. Gear's down. 240. 230. 220, lots of speed. Beautiful. 210. 210. 200. 195. Get the speed brakes are coming. Okay, 60 knots. Try the nose wheel. Okay. That was too good a glider.
Picture book flight, wasn't it? Congratulations, boy. Thank you.
To fly into space, the shuttle needed rocket motors a lot more efficient than engines used to put Apollo on the moon. With new ways of making special parts, engineers developed innovative ideas for a motor that had to fire again and again and again. Shuttle engines would be throttled up and down and last for at least 50 missions. No one had built rocket motors to do that before. Heat-protective tiles built to last at least 100 flights would insulate the metal skin from high temperatures on re-entry. Made from a silica fiber, they were quite unlike ablative shields designed to burn slowly, tiles would simply glow and last a very long time. Space Shuttle Columbia was towed from its hangar to the giant assembly building, and all across the Cape, technicians and engineers groomed elements of America's new space program. At launch, the shuttle would weigh 2,000 tons and leap towards space with the power of 200 million horses. It was a marriage of the rocket and the aeroplane that many had thought would be the way men first went into space. Now, picking up the challenge of a true spaceplane set by Scott Crossfield in the X-15 2 decades before, American astronauts were going back into orbit. Bob Crippen joined the astronaut team in 1969. His commander, John Young, had been in space 4 times. Their special suits would protect them if they ejected on the way up or down, different from the spacesuits carried on later flights. In the pre-dawn hours of April 12, 1981, 20 years on from the day Yuri Gagarin became the first man in space, Young and Crippen rode a bus to Launch Complex 39, where a space plane stood waiting.
The firing system for the sound suppression water will be armed.
And from their position high atop the launch pad, the two men got ready to fly the world's first shuttle.
Instrumentation recorders are on. We're just a few seconds away from switching to the redundant sense sequencer. T-minus 27 seconds. We have gone for redundant set sequencer start. T-minus 20 seconds and counting. T-minus 15, 14, 13, T-minus 10, 9, 8, 7, 6, 5, 4. We've gone for main engine start. We have main engine start. Mark, 2 minutes, 20 seconds. Confirm solid rocket booster set. On-board guidance is converging as programmed. Columbia is now steering for its precise window in space for main engine cutoff. Standing by now for external tank separation. Roger, we confirm the SEP, Columbia. 9 minutes, 3 seconds. Confirm external tank separation. Columbia now performing an evasive maneuver, moving below and beyond and translating to the north of the external tank. Young should see it moving away out his window.
Columbia, Houston, your go for nominal ohms 1, and for APU shutdown on time.
Less than 9 minutes after liftoff, the shuttle was in space, with Crippen getting ready to stow unnecessary gear and open the payload bay doors. The cavernous bay was 60 feet long, the light graphite doors fitted with radiators for getting rid of excess heat, serving to protect cargo placed inside for launch. No sooner had the cameras turned on than controllers saw a few missing tiles on one of the engine pods. But they were in an area which would keep fairly cool on re-entry and pose no problem for the landing. The huge payload bay could carry up to 30 tons of cargo on later flights. But for the first, a package of instruments.
We're trying to put that on TV right now.
Roger, Crip, we can see that good.
Down below the flight deck, a spacious living area served as bathroom, toilet, exercise pad and galley. And below that, a basement cellar for equipment and supplies.
CDR seat, and you might tell me how your reception is.
Okay, we've got a good picture, Crip.
All too soon, it was time to head for home and carry out the first glide re-entry with a winged vehicle flying at 25 times the speed of sound. The payload bay doors were shut, and 2 days into the mission, the shuttle got ready for its biggest test yet. They would soon know if those tiles worked.
John and Crip, we're 30 seconds from LOS. Want to report that Columbia...
2 engines at the rear of the shuttle fired briefly to slow it enough for a long glide toward thin air, and then full deceleration in the denser atmosphere below.
The burn.
Marked Mach 9 at 9,700 feet per second.
Columbia, you got perfect energy, perfect ground track.
Roger that.
And John, we're showing you rolling right. Looking good.
Chase will be on time.
Okay.
Columbia, you're really looking good. Right on the money. Right on the money. Welcome home, Columbia. Beautiful, beautiful.
We'll stop.
This is Mission Control, Houston. The unofficial...
On its very first flight, everything had gone better than best hopes indicated it might. But there was still a lot to do, and many tasks to carry out to make it safe for the crew to emerge.
At least 26 more minutes on the ammonia. You're looking real good.
John Young led Crippen down the steps, the first Americans to walk away from a manned spacecraft.
Instructions were prepare for
For 12 years, 50,000 people had worked to make the shuttle a reality. Now 2 men had literally flown back from space, and a new window opened on an age of space, unlike anything yet seen. Designed to provide economic and affordable access to space, the shuttle is based on reusing as much as possible after each mission. The big boosters lifting shuttle on its way are jettisoned on the way up and recovered for use on a later flight. In this way, costs are kept down to help lower fees charged for launching satellites. Only the big external propellant tank is thrown away on each flight, tossed into the ocean where it breaks up harmlessly. Recovery costs work out more expensive than production, so here too the shuttle is economical. The 5th flight took 4 men up for the first time, but its purpose was to deploy 2 satellites, one for Canada and one for Indonesia, shuttle's first commercial payload.
Santiago AOS is 8:11:02. We're looking forward to a good deploy report. Everything looks right on the money to us down here right now.
Set spinning for stability, each satellite was held by clamps to a special table. Just at the correct place in orbit round the Earth, the astronauts set instruments to launch the satellite. Traveling at 5 miles a second, their timing was crucial. At the precise moment, 3 little springs pushed the satellite free. It was as simple as that, but a beautiful sight for all aboard Columbia.
We got SPS off on time, and if you're interested, I'll read you the pad.
Roger, go ahead.
Okay, current attitude, 24.19er, 87.41, 292.65, errors, plus 0.08, minus 0.08.
We have main engine ignition.
Proving that what goes up need never come down, 2 empty places for satellites now in orbit. But the mission did have some failures. 2 malfunctioning spacesuits prevented a planned spacewalk, a legacy for the 6th mission, the first flight of NASA's second shuttle called Challenger. Launched 2 years to the day after Columbia's first flight, Challenger gave 4 men a ride and a spacewalk for 2 along a very precarious handrail.
Touchdown time at 5 days, 0 hours, 23 minutes, 42 seconds.
Running to keep up with a male-orientated job, astronaut Sally Ride would become the first American lady to fly in space. Russia launched its second woman cosmonaut just before the 5th shuttle flight. But Sally would fly with 4 men on a flight to launch satellites and stretch the bionic arm in a demonstration of how it could capture and retrieve satellites already in space. With fittings for her space hat and training that made no concessions, Sally had to do everything the guys did and more. Training was always strenuous, and the less physically strong just had to work harder. Ejection seats had been removed from the shuttle after Columbia's 4th flight. But if it ditched at sea, shuttle would make a terrible boat. Water survival was essential. And weightless training was a great equalizer. Central to the success of Shuttle's 7th mission was the huge arm that would grapple a German satellite back in the payload bay after first deploying it in space.
7, 6, we go for main engine start. We have main engine start and ignition and liftoff. Liftoff of NCF-7 and America's first woman astronaut. And the shuttle has cleared the tower. Roll program.
Roger your roll, Challenger.
Houston now controlling. Mission control confirms roll maneuver started.
Ground com on all F channels 217, 218.
20 seconds. Thrust looks good. 25 seconds. Roll maneuver completed. Challenger 21 nautical miles in altitude. Standing by now for solid rocket booster separation. 12 minutes, 12 seconds. Confirm good solid rocket booster separation. The booster's falling away now.
Challenger Houston, your go for nominal ohms 1. APU shut down on time.
Roger that.
Commanded by Bob Crippen, the flight was the first to carry 5 people into space, and Sally was in her element. A quick burst from a rocket motor sent a shiver through Challenger, the camera bouncing in its bracket.
Okay, Houston, things are looking good on board.
Roger, we copy, and you all look good.
Also on hand, a pharmaceutical test rack for the new vaccines promised from space manufacturing plants.
Roger, and we'll have you for about 2 more.
The answer is there is no problem.
Yargety's next at 1+4, sir.
Even on board, Sally was still running, but not to catch up.
Roger, you might check a camera
Roger,
over
we
temp,
understand. We saw some good views of the Earth through your cameras.
And a
as well
candy
as-
bar did taste very good, even on the jog.
Wonderful, wonderful.
And the mass spec is...
But sometimes the most sociable astronaut needed moments of privacy, a modesty not seen on earlier
We're
flights.
working on a go for the R-bar separation, but we need the processor temp.
Now it was time to put out the German satellite, fly off, come back, and retrieve it for return to base.
And TJ, we just turned on the mass spec to...
The operation was a dazzling success and revealed new fields in which the shuttle could best provide its services to man. With a myriad escorting satellites, relaying communication, storm warnings, and a promise of better and more effective ways to manage the global garden, shuttle could become custodian of a better world. Space fills the needs of man, as countless lives saved by satellites now testify.
And the answer is
if space can be a preserved arena for combat against common threats from pollution, malnutrition, starvation, and thirst, it will have served man very well. Man went to the moon not because of his technology, but because of his imagination. Denied that imagination, he cannot best deploy the technical resources here today for a better world in the future. The shuttle is the foundation on which that future rests. But all this is not inevitable. Built by a group of European countries, a laboratory designed to fit inside the shuttle will give scientists a new look at making things in space for people on Earth. To fill the shuttle's enormous cargo bay, Space Lab provides room for several scientists to work together. Astronauts will work in the laboratory to seek ways of preparing new medicines, growing semiconductor crystals for the electronics industry, and preparing new alloys. Space Lab will revolutionize the way we understand science. In the second half of the 1980s, a 20-ton telescope will be carried into space by the shuttle. With this instrument, observers will see 350 times the volume of space seen by the most powerful telescopes on the ground. New machines will fabricate structures and steelwork to build stations and bases in space. On each mission, beam builders with rolls of aluminium will fabricate girders a mile long, from which orbital Spidermen will construct huge platforms. From these, giant assemblies would grow to make solar power satellites, each generating the output of a nuclear power station on Earth. The fiction and fantasy of today will emerge in another century as the first space cities of a new cosmic age. In huge cigar-shaped colonies, Earthlings will create a world of wonder to rivet the imagination, renewing in space opportunities lost on planet Earth. And beyond the limits of time, the Earth, the planets and the Sun will be left as a dim reminder of where it all began. Life itself will have outlived the solar system that gave it birth. The choices before man today are clear. He lives in ever-enriching harmony with the universe or dies, forgotten on a wasted planet. It could be that this will be the end of man's story on Earth, for it will be the genesis of a new race, a man whose being extends into the furthest regions of the cosmos.
And there we end this fascinating program on space exploration. Because the series was made prior to the recent Challenger accident, some facts stated in tonight's program are now no longer valid.